Hey guys, so this is a video that is about trig graphs with phase shifts and vertical shifts. In your notes, it says transformations, phase shifts, and vertical shifts. So get to that page on your notes. I'm going to go through the notes with you, and I'm also going to do two examples with you. Okay, so these functions listed over here on the side are kind of what you're going to look at. Those are your general functions, but I'm going to explain it to you on the right hand side. It's the same with sine, cosine, and tangent. You just replace it in there. So like other functions, trigonometric functions can be translated. A phase shift shifts horizontally. If it says plus h, if you look over here on this equation, see how it says minus h? That means that it's going to be the opposite of what you think it is. So if it says plus h, instead of going right, it's going to go left. And minus h means that it's going to go right. For example, if y equals the sine of theta minus pi, it's subtraction, and in the original equation over here, it's subtraction. So it's going to shift by pi, because that's what we're subtracting, and it's going to go to the right. These are kind of weird because they're the opposite of what you think they would be. The next one, where y equals the tangent of theta minus pi over 4, we're going to shift by pi over 4. And it says plus, so we're going to go to the left. It's the opposite of what you think it would be. The next part is vertical shifting, and I am going to erase this stuff over here so that we can kind of see what's on the original equation. So see how it says plus k? That means it's going to do exactly what we think it's going to do. So when it says plus k shifts, well, it's the same as, sorry guys, my video cut out. When it says plus k, it's going to shift up, and when it says minus k, it's going to shift down, because in our general equation, it says plus k. So if we have tangent of theta plus 2, that's going to shift it by 2, and it says plus, so it's going to be up. When it says cosine of theta minus 4, don't put shifts minus 4. Put shifts 4, and then it's down. Never put the positive or negative in there. Just like we did with the phase shift, we did not put the positive or negative in there. Now let's look at our general equation. This number a out front, we know that a does not mean amplitude with tangent, because tangent has an undefined amplitude. But with sine and cosine, this is going to be your amplitude. And then we know that the b affects our period. And we know that period with sine and cosine is 2 pi over the absolute value of b. Then we know that h is going to be our phase shift. And we know that k is going to be our vertical shift. It's super important that you have this written down, because this is what you're going to do for all of these from here on out. Okay, for the next part, we're going to talk about midline. And midline literally means the middle of this function horizontally. So the midline is right there on that part, and the midline's right there on that part. It's just the middle of that function. So really, it's how far you would go with the amplitude. So shifting a graph vertically will create a new horizontal axis called the midline. This is the reference line to which a graph oscillates. The equation for the midline is y equals, and on this one you can see that you go 1, 2, 3, 4 up, so it's y equals 4. If you notice something on this equation, look at this number at the end. It's 4. So that vertical shifting is going to be your midline on these. Okay, let's try these first two problems. We know that the amplitude is always that number out in front, so in this case, our amplitude is 1/2. With period for sine and cosine, it's 2 pi over the absolute value of b. So in this case, it's 2 pi over the absolute value of 3, which is just 3. So we have 2 pi over 3. The phase shift. Now remember, phase shift is always inside the parentheses. We don't have parentheses here, so we don't have a phase shift. The vertical shift is always this number added or subtracted at the end. Don't say -5, say down by 5. That negative means down. And the midline on this is associated with the vertical shift. So our midline, it's going to move this whole function down by 5. So our midline is going to be y equals -5. Okay, let's do the next one. The number out front is the amplitude, except for we don't have amplitude with tangent, right? So it's just undefined. Now the period is going to be pi over the absolute value of b with tangent. So it's going to be pi over the absolute value of 2. So it's just pi over 2. Now our phase shift is what is inside the parentheses. So it's 2 pi. And remember, it's the opposite way we want to think of it. It's positive, but it's going to be to the left. Okay, now the vertical shift is what's outside the parentheses, and remember it's the same. So it's going to be 1. Don't write +1, please. But the 1 does mean that it's going to go up. And lastly, remember vertical shift and midline correspond with each other. So our midline is going to be at y equals 1 because it would be the x-axis, but it's moved up by 1. Okay, I just want to relabel this diagram again really quick because we're going to use it for literally all of these problems. So let's just go ahead and label it. So remember the A is the amplitude. The B affects the period. And remember that the period is 2 pi over the absolute value of b. So if you have -2 there, it's going to be 2 pi over +2 because it's the absolute value. The H affects the phase shift. And the K affects the vertical shift. Okay, so let's go ahead and graph this one. If you guys go to your notes, this is still on the notes part, not on homework 10, but it is problem 4. Okay, one thing that I want to mention, because it's completely going to change your graph if you don't do this in the right order. Graphing sine, cosine, tangent, secant, cosecant, and cotangent has an order of operations, but it's a little different than what you would think. Usually you'd think you'll do what's inside the parentheses first, and it's really the opposite of that when you do these. When you do these, remember how we taught amplitude and period first? We're just now getting to vertical shift and phase shift. And that's how it's going to be with this as well. When we do this, we want to do the amplitude and period first, and then we want to do the phase shift and vertical shift. So let's just start with our parent function for tangent. So our parent function is just going to be y equals tangent of theta, right? And let's put some points on here. So let's use our common ones. So we're going to have negative pi over 4, -1, 0, 0, and we're going to have pi over 4, 1, And then let's also do this to two of our asymptotes. So let's do this to negative pi over 2 and pi over 2. Now next we need to do our amplitude, right? So our amplitude is going to be y equals 1/2 tangent of theta. And this means that we need to multiply all of our y's by 1/2. Remember, amplitude is multiply. So we're going to take all of our y's and multiply them by 1/2. So we're going to get negative pi over 4 still, negative 1/2, 0, 0, pi over 4, 1/2. And remember that these asymptotes are x's, so we're just going to put those over here. Negative pi over 2 and pi over 2. We're not going to change those because those are x values. Next, we need to do this vertical shift. We don't have a changed period in this case because there's no b there. We don't have a phase shift because that 3 is not inside of the parentheses. So vertical shift. That means we're going to move up or down, right? And the one outside of the parentheses, see how this says positive k? That means we're going to do exactly what we think it means. So it says minus 3. That means we're going to move down by 3. So that means all of those y values, that means we're moving down. So that's the y direction. So we're going to subtract 3 from all of those y values. So I'm going to write subtract 3. So we're going to have negative 1/2 minus 3. So that's actually going to be negative 1/2 minus 6 over 2. So we're still going to have negative pi over 4. And then we're going to have negative 3. Whoops, sorry. I was just looking at that last fraction. Not negative 3. We have negative 1/2 minus negative 3. So we're going to have negative 1 minus negative 6, so we're going to have negative 7 halves. Then we're still going to have 0, 0 here. Oh, we're going to have 0, negative 3. Then we're going to have pi over 4 still. And we have 1/2 minus 3. So we're going to have 1/2 minus 6 over 2. So we're going to have 1 minus 6, so negative 5 halves. And then these are still going to be the same, negative pi over 2, because we're changing the y, not the x, and pi over 2. Okay, let's fill in these values that we already know over here on this side part. So we know the amplitude is this number out front, so our amplitude is 1/2. Our period isn't changed, and the period of tangent we know is pi over the absolute value of b. Well, if there's nothing there, remember we call it a ninja 1, so it's pi over 1, which is just pi. And then our phase shift, do we have a phase shift? Is there anything inside the parentheses? Nope, so there's no phase shift. Our vertical shift is that number at the end, and remember, don't say negative 3. We're going to say down by 3. Our midline is moving down by 3, so it's going to be y equals negative 3 instead of y equals 0, which is what the parent function midline is. Okay, now let's go ahead and graph this first period that we have all of these points for right down here. And we have our two asymptotes. I'm going to graph my asymptotes first at negative pi over 2 and pi over 2. And then I'm going to graph my points, which are at negative pi over 4 negative 7 halves, which is 3.5. So there's my first point. And then I have 0, negative 3. And I have pi over 4, 5 halves, which is 2.5. So this whole function moved down. Remember, it makes kind of a swirly shape. Okay, now we have to continue this to the edge of the graph. So this is 1, 2, 3, 4 units between the asymptotes. So I'm going to do 1, 2, 3, 4. And my next asymptote is going to go at 3 pi over 2. Then I'm going to have negative 3 pi over 2. And for my points, on the center, it looks like it goes down to negative 3. Then we go over 1 to the left and down by a half. We go up by a half and over 1 to the right. And then over here, it's going to do the same thing, but we only have 2 pi, so we're going to have a point here, here, and it's going to go up a half and over by 1, so it's just going to go to the edge. Now let's go the middle, over 1. That looks pretty good, and then let's do the same thing on the last period that we have on here. Okay, I am going to graph the other one of these for you guys in a different video. It's going to be problem number 5, which is y equals 4 times the cosine of theta minus 3 pi over 4 minus 1. I'm going to do it in a separate video because this video is getting super long. So if you feel like you've got it after this, go for it. You're good to go. If you feel like you need another example, I would watch the next video.